Welcome to ISLAC. In this lesson we'll explore logic gates, the tiny decision makers inside every computer. By the end you'll recognize all 6 gates, read their truth tables, and combine them into working digital circuits. Let's get started. Here's our roadmap. We'll define what a logic gate is, meet all 6 gates, learn to read and build truth tables, write Boolean notation, and finally combine gates into circuits. Keep these objectives in mind as we work through today's lesson. Computers understand only 2 things, on and off, 1 and 0. Logic gates take these binary signals and make decisions with them. Every calculation, every pixel, every game, it all comes down to gates switching electricity on and off. Quick recap. In digital electronics, a 1 means true, on, or high voltage. A 0 means false, off, or low voltage. That's the entire alphabet computers use. Everything else, gates, circuits, and programs, is built from just these 2 states. A logic gate is a tiny electronic component. It takes 1 or more binary inputs and produces exactly 1 binary output. The output depends only on the inputs, following a fixed rule. We describe that rule using a truth table, coming up next. A truth table lists every possible combination of inputs and the output each produces. Inputs go on the left, output on the right. With 2 inputs there are 4 combinations. With 3, 8. Always complete every row. Examiners love a missing one. The NOT gate, or inverter, has a single input. It simply flips the signal. Input 0 gives output 1, and input 1 gives output 0. We write it as a with a bar on top. Notice the little bubble on the symbol, that means invert. The AND gate outputs 1 only when all its inputs are 1. Any 0 on the input, and the output drops to 0. Think of it as, this and that must both be true. We write it A.B, like multiplication. The OR gate outputs 1 if any input is 1. It only gives 0 when every input is 0. Think, this OR that, at least 1 must be true. We write it A plus B, like addition. Notice the curved back edge on the symbol. NAND means NOT and an AND gate with its output inverted. It outputs 1 for every combination except when all inputs are 1. The symbol is an AND shape with a bubble on the output. Watch that inverted final row carefully. NOR means NOTOR, an OR gate with its output inverted. It outputs 1 only when every input is 0. Any input of 1 makes it 0. The symbol is an OR shape with a bubble on the output. It's the exact opposite of OR. XOR, the exclusive OR, outputs 1 only when its inputs are different. 2 the same, both 0 or both 1, give 0. XOR is the gate behind binary addition. We write it A, plus in a circle, B, and the symbol has a double curved back edge. Here are all 6 gates side by side, symbol, rule, and Boolean notation. Pause and study the patterns. Notice how NAND and NOR are just and OR inverted, and how XOR stands apart. This slide is your quick revision reference. Boolean notation is shorthand for gates, and is a dot BOR is a plus B not is a bar over the letter. XOR is a plus inside a circle. Learn these, you'll need them to read and write logic expressions. Real circuits combine gates. Here's Q equals A and not B. We first invert B with a NOT gate, then feed A and not B into an AND gate. Follow the wires from left to right, the output of one gate becomes the input of the next. Let's build its truth table. List all 4 combinations of A and B, work out not B, then init with AQ is 1 only when A is 1 and B is 0. Just one row satisfies the condition. Always work column by column. A practical example, a burglar alarm. It sounds when the system is armed and either a door or a window opens. That's a 3-input circuit, an OR gate feeding into an AND gate. Logic gates aren't abstract, they run the technology all around you. Exam tips. Don't confuse an OR. AND needs all inputs true, OR needs just one. Remember NAND and NOR are inverted. Draw the correct symbol shapes with bubbles. And complete every truth table row. That's where easy marks are lost. Let's recap. 6 gates, not inverts, and needs all, OR needs any, NAND and NOR are their inverses, and XOR fires on difference. You can read truth tables, write Boolean notation, and combine gates into circuits. You now hold the building blocks of every computer. That's logic gates. Test yourself with the quiz link below, and if this helped, hit subscribe for more IGCSE computer science lessons. Like the video, drop your questions in the comments, and I'll see you in the next one. Thanks for watching.